Okay, so this video is about 7.1, which is our introduction to hypothesis testing. So this is a pretty key component of statistics. So what we're going to do is we're going to use a hypothesis test to check to see if a sample statistic um, supports a claim about a population parameter or does not support the claim. So, a real life example, we have an automobile manufacturer that is advertising a new hybrid car that's getting a mean mileage of 50 miles per gallon. So, we would test the claim by taking a sample, and then if the sample mean is different from the advertised mean, we can decide that the advertising is false. So, pretty practical, right? All right, so a statement about the population parameter is called our statistical hypothesis. When we're testing our population parameter, we are going to use a pair of hypotheses. One represents your claim, and the other one is going to be its complement. This is kind of like when we were doing probability, and if I told you what's the probability of rolling a 2 on a standard die, you would say you have a 1 in 6 chance. So what's the probability of not rolling a 2? That would be 5 out of 6. So when one of the hypotheses is false, the other one has to be true because they're opposites of each other. So we have a few key definitions. So we have the null hypothesis. This hypothesis has to have an equality statement. So it has to have an equal sign with it. It can be a less than or equal to or a greater than or equal to. We read this as H naught or H sub 0. I usually call it H naught or just null hypothesis. Then the alternative hypothesis, this is going to be the complement to your null hypothesis, and it's going to use signs such as greater than, not equal to, or less than. We call this one HA, or you could even say H sub A. I usually just say HA. Okay, so what we're going to do when we work through these problems is we're going to take the claim that they make about your population and turn it from a verbal statement into a math statement, and then you're going to write the complement down. Regardless of which pair of hypotheses that you use, you always assume that U is equal to K. And examine the sampling distribution on the basis of this assumption. And I'm going to show you what this means with a real example. I think it'll make it more clear. But essentially, when you're looking here, we've got all of our complements that we can have. Okay, so notice H naught has the equal signs with it each time, and the HA is the opposite of whatever our H naught is. Okay. Okay, so let's go ahead and put this in for a real example because I think it'll make everything a little bit more clear. So the first thing is we are writing the claim as a mathematical statement, and then we're going to state the null and alternative hypothesis, and then identify which one represents our claim. So a school publicized the proportion of students who are involved in at least one extracurricular activity is 61%. Okay, so our claim is, oops, I'm hitting the button. Okay, so that's our claim. The opposite of that is going to be not equal to. Okay, so all we have to do now is, oh, I thought it changed the color. Neat. Okay, I did change color. All right, so H naught is going to be, and this one's our claim. And then the opposite of that is going to be our alternative hypothesis. There you go. Okay, let's do another one. All right, same thing. A car dealership announces that the mean time for an oil change is less than 15 minutes. Okay, so we're going to start with our claim. They're saying that mu is less than 15 minutes. So the opposite of that is going to be the mean time is greater than or equal to 15 minutes. Okay, so now this part's a little bit tricky. So remember, your null hypothesis always has the equality sign, okay? So that means the equal sign has to go with your null hypothesis, okay? So we're going to say the null hypothesis is that the mean time is greater than or equal to 15 minutes. And our alternative hypothesis, which is our claim in this case, is less than 15 minutes. Okay? All right, let's do one more. Okay, so a company is advertising that the mean life of its furnaces is more than 18 years. Okay, so their claim is the mean is greater than 18. Okay, what is complementary to that statement? That the mean is less than or equal to 18 years. All right, so which one is my null hypothesis? This one or this one? Hopefully you're saying the one on the right because it has an equal sign with it. And then HA. There you go. Fantastic. All right. Okay, so I want you to try this. So pause the video now and try these three on your own, and then we'll see how you do. Okay, so hopefully you actually did pause the video and tried these. We're doing the same thing that we just did together. So a consumer reports that the mean life of a certain automobile battery is not 74 months. Okay, so we're going to say the claim I'm just going to rewrite that. It's messy. Okay, here we go. So claim mean is not 74 months. So the complement to that is that it is equal to 74 months. All right, now which one is my null hypothesis? This one. And then this one is my alternative. All right, an electronics manufacturer publishes that the variance of the life of its home theater systems is less than or equal to 2.7. Okay, so variance, so claim, variance is less than or equal to 2.7. What is complementary to that? Greater than 2.7. Okay, and which one is H naught? Here we go. And my alternative is here. Okay, so remember, H naught has to have that equal sign. All right, a realtor publishes that the proportion of homeowners who feel their house is too small for their family is more than 24%. Okay, so their claim here is greater than 24%. Complementary to that is less than or equal to 24%. All right, which one's H naught? This guy right here, and HA is right there. Fantastic. Okay, so now we have two types of error that can happen with this. Okay, so we call the errors type 1 and type 2. I know, super creative. So what we do for this is we always are going to state things in terms of the null hypothesis. That's just convention. And the reason why we get errors is because we are only taking a sample of the population. And so in that, there's a possibility that the sample is, I don't want to say incorrect, but sometimes, like, let's say you pick a poor sample, not purposefully, you just pick a poor sample, you could make a wrong decision. So the two things that are going to happen at the end of your hypothesis test is you're going to either reject your null hypothesis or fail to reject it. You never say you support the alternative hypothesis. You always say we reject the null or we don't reject the null. Okay. So let's see this here. I like this chart a lot. So we have a couple of different outcomes that can happen. If your H naught, your null hypothesis is true, then you're not going to reject it, and that's correct. But sometimes you can get a type 1 error when you reject the null hypothesis when it is actually true. Type 2 error is when you don't reject your null hypothesis, but it is actually false. So you should have rejected it. So I think this will make sense when we put it into an example. So let's go ahead. Chloe, get off the computer. Yeah, I know you can't stand on the computer, baby. Okay, so think about hypothesis testing when you think about the legal system in the US. So what we do when somebody goes to trial is they carefully word their accusation. The defendant is assumed innocent, H naught, until proven guilty. The burden of proof lies with the prosecution. So if your evidence is not strong enough, there's no conviction. A not guilty verdict does not mean your defendant was actually innocent. It just means there wasn't enough evidence to show that they were guilty. The evidence has to be conclusive beyond a reasonable doubt. So the system is assuming that there is going to be more harm done by convicting an innocent person, type 1 error, than not convicting a guilty person, type 2 error. Okay, so let's go ahead and put a real life example with this. I mean, that was a real life example, but let's work through one, okay? So we have the USDA is going to limit the salmonella contamination for chicken at 20%. The meat inspector reports that the chicken produced by a company exceeds the USDA limit. You perform a hypothesis test to determine whether or not the meat inspector's claim is true. When will a type 1 or type 2 error occur, and which one is more serious? Whoa, whoa, whoa. There's a lot going on here. Okay, so the claim is that the salmonella level exceeds the USDA limit. So that means, okay, let me write this down. The claim is that the level is above the 20%. okay? So the complement to that is going to be less than or equal to 20%. Okay, so now we're going to identify which one of these is my null and which one of these is my alternative. Okay, so HO is going to be less than or equal to 20%. My alternative hypothesis is going to be greater than 20%. Okay, so thinking about our errors, we have type 1. And remember, for type 1, you're rejecting H naught, but it's true. Okay, so think about this. If we're rejecting H naught, that means we are saying that there is not enough evidence to show that the level of salmonella contamination is less than or equal to 20%. So what this means is you're probably going to freak a lot of people out, even though you shouldn't freak them out, because the H naught is actually true, okay? So it's saying we are telling you that the level of contamination is above 20% when it's actually not above 20%. So what will happen here is it might create a sense of false panic. And it might even cause the sale of chicken to go down. All right, now type 2. So type 2, we are not rejecting H naught, but it is actually false. Okay, so what this means is the loading. Okay, so what this one means is we did not reject our null hypothesis. So we did not say that the contamination level was not less than or equal to 20% when we should have rejected it, because that's not true, okay? So what this means is we could potentially be selling contaminated chicken. So which one do you think is more serious? Selling contaminated chicken or saying it's contaminated when it's actually not? Hopefully you said type 2. Okay, so the more serious one is type 2. Okay, we got another example. And I want you to pause this and I want you to try it. So we have a company that is specializing in parachute assembly, and it states that the main parachute failure rate is more than 1%. You're going to perform a hypothesis test to evaluate whether the claim is false. When will a type 1 or type 2 error occur, and which one is more serious? Okay, so our claim is that the failure rate is not more than 1%. So it's less than or equal to 0.01. The complement to that is that it is greater than 0.01. Okay, so which one is the null and which one is alternative? So here's my null, and here is my alternative. Okay, so type 1. We're rejecting the null hypothesis when it is actually true. So this is saying, we're saying the failure rate is not less than or equal to 1%. So we're saying it's more. And so when this type of error occurs, it's going to probably hurt the sales of the skydiving company. All right, type 2. So type 2 error is when we are failing to reject our null hypothesis. So this type 2 error is saying that we didn't reject that the failure rate was less than or equal to 1% when it actually was not less than or equal to 1%. So it's more than that. All right, so this one is more serious because it's going to mislead your consumers, and they're going to be feeling like they're safer than they actually are. So type 2, again, is more serious. So the next thing that we're going to talk about is we're going to talk about the level of significance. This is the maximum allowable probability of making a type 1 error. So remember, your type 1 error is rejecting your null hypothesis when it's actually true. We represent the type 1 error significance level with the Greek letter alpha, and we use beta for our type 2 error. So the commonly used ones are 0.1, 0.05, and 0.01. Okay, we want this to be small so that the probability of rejecting our true null hypothesis is also small. Okay. All right, so what we're going to do is we're going to state our null and our alternative hypothesis, and then you're going to specify your level of significance. You're going to take a random sample from your population, and then you're going to calculate your sample statistics. The statistic that is compared to the parameter in the null hypothesis is called your test statistic. Okay, so this should be relatively familiar because we just finished talking about like the z-test, the t-test, the chi-square distribution. Okay, so it's all going to kind of come back in this next chapter. Okay, so if your null hypothesis is true, a p-value or probability value of the hypothesis test is the probability of obtaining a sample statistic with a value as extreme or more extreme than one determined by the sample data. The p-value is going to depend on the nature of your test. So we have a couple of different tests that we're going to run here, and they're based on the signs that we use for our null hypothesis and our alternative hypothesis. So When we have our null hypothesis is greater than or equal to some value, we're going to use our left tail test. The opposite of left tail is a right tail test. So when your null hypothesis is less than or equal to, you're going to use a right tail. And when we have the equal or not equal with our null and our alternative hypothesis, that's when we use our two-tailed test. Okay? All right. So let's run through a couple of examples that you probably remember because we just did them and determine which test we are going to use. Okay? All right, so this one you should remember we had the school that was publishing the proportion of its students that were involved in at least one extracurricular activity is 61%. Okay, so remember our claim was it equals 0.61. And the opposite of that, it doesn't equal 0.61. Our null and our alternative are there. And since we have an equal and not equal to, we are going to be using a two-tailed test. Okay. All right, next one. All right, our car dealership is saying that the mean time for the oil change is less than 15 minutes. Okay. So remember our claim was that our mean was less than 15. The opposite of that is greater than or equal to 15. Our null, our alternative. All right, so since we have our null being greater than or equal to, this one is going to be a left-tailed test. All right, one more like this. Okay, so we have the company that is advertising that its mean life of furnaces is more than 18 years. Okay, so the claim is it's greater than 18 years. The complement to that is less than or equal to 18 years. Null hypothesis, alternative hypothesis. All right, so since this is our combination here, this one is going to be a right tail test. Okay, and we're going to be working more with this. Right now, the key thing that I want you to take away from this is being able to identify when you're using what test, okay, because that's going to come into play later. Okay, so making your decision. You are going to compare the p-value, your probability that you got, with the level of significance. If your probability is less than or equal to the significance level, you're going to reject your null hypothesis. If it is greater than your significant level, then you are going to fail to reject it. Okay, so this chart can help you make your decisions. So let's go ahead and put this in an example. Okay. So we are performing an hypothesis test for the following claim. Chloe. How should you interpret your decision if you reject H naught? How should you, what if you fail to reject H naught? Okay, so the claim was the school publicizing that the proportion of students who are involved in at least one extracurricular activity is 61%. Okay, so if you were rejecting that, I'm going to type this out because it's going to be a little bit more. All right, so if you're rejecting that, you would say there is sufficient evidence to reject the school's claim that 61% of students participate in at least one extracurricular curricular activity. All right, so then the opposite of that, failing to reject it, is going to be a very, very similar statement. But instead of us saying there is sufficient evidence, we're going to say there is not sufficient evidence to reject the claim. Okay? So there either is going to be significant evidence to reject it or not significant evidence to reject it. Okay? Let's do another one. All right, so for this one, this was the car dealership saying that the mean time for oil was less than 15 minutes. So our claim for this was that our mean was, let's see, symbols. All right. So remember, we always are looking at this in terms of H naught. So if we're rejecting H naught, we would say there is enough evidence to support the dealership's claim that the mean time for an oil change is less than 15 minutes. Okay. Then if we fail to reject, it's pretty much going to be the opposite of what we just wrote down. There is not enough evidence to support the dealership's claim that the mean time for oil change is less than 15 minutes. Okay. All right. So, in summary, you got 4 steps. First, you're going to state your hypothesis pair and identify which one is the claim. And then you're going to complete the appropriate test. So right tail, left tail, or two tail. Then you're going to make your decision whether or not to reject or fail to reject. And then you're going to interpret that decision within the context of your original claim. Because if you remember, the claim is not always going to be your null hypothesis. Sometimes it's the alternative hypothesis. Okay, so let's go ahead and... Okay, so our last 2 examples. We have a medical research team that's researching the benefits of a new surgical treatment. One of the claims is the recovery time for patients with the new treatment is less than 96 hours. Okay, so the claim is the treatment is less than 96 hours. Okay, which means the complement to that is the treatment is greater than or equal to 96 hours. So our null hypothesis in this case is going to be and our alternative hypothesis is going to be there. All right, so we want to support the claim. So since we want to support the claim that the mean treatment time is less than 96 hours, we're going to actually reject the null, okay? So we want to okay? Okay, so let's think about this. Same example, but I'm on the opposing team, okay? So since I am on the opposing team, I want it to be not less than 96 hours. I want it to be greater than 96 hours. Okay, so the complement to that is that it's less than or equal to 96. Okay, so that's my claim. All right, this one is still going to be H naught because it's got the equal to. This is going to be my alternative. So if I'm on the opposing team and I want to reject the claim, I'm going to reject the null. Okay. So you see how those two are different based on whose team you are on for the research study. So if you're feeling a little bit overwhelmed, don't worry. You're going to get some practice with this on your homework. And if you have questions, let me know. I'm available for help as well.